The EaganMatrix has for quite a while supported a graphing function that allows you to change the mode amplitudes of a BigGraph. This used to be called a BiqMode. That's used in a number of presets, for example, the Woodwind preset. This allows you to define a main graph here of amplitudes and one or two graphs of amplitude offsets that you can apply to the main graph to basically let you change the spectral content of a preset in a very dynamic way. You can hear if I play that, and now I'll take that first mode, which is set to its maximum value, and I'll remove it. You can hear how I can very easily change the spectral content of a sound this way. Well, in 9.95 and future releases, this graphing function has been enhanced to allow you to create patterns of values that you can use as notes. If I select the BigGraph on an empty preset and select the main graph, you can see that you can define up to 48 values. And if I hover over one of them and then look at the key up top, you'll see it tells me what index I'm on. Here, number 1. Now I'll change to number 2 since I've moved the cursor. It'll give me an integer value assigned to that position. And if I'm using a mode attenuation instead of interpreting it as an integer, that tells me what the dB value of that would be. We're going to be interested in using these things as integers in this video. Now currently, let's select both BigGraphs. The graphs are shared between all the BigGraphs and the note graphing function as well. You'll notice there are 3 new controls that map to each one of the 3 graphs underneath the control panels that were in the previous release. I can select one of these icons to move between the 3 graph types. I'll select some random pattern here, and you'll see if I go to the first BigGraph and select that and then the second, there's only one set of these graphs currently. So you can't use a BigGraph and this note function at the same time, and you don't have to have a BigGraph selected to move back and forth between these graphing functions. So how do we apply these graphs? The main graph we saw you can set from values 0 to 96. If I wanted to, I could use that as a Midi Note number 0 to 96, but we'll use these graphs as offsets to a base Midi number. You'll see it's more flexible and you'll be able to map to your keyboard or continuum ranges better. An easy way to think of these values are scale degrees. So using a C base offset, that doesn't mean we have to be in the key of C. I'll use these numbers as scale degrees to define a note pattern. I've defined 4 different patterns in this 48 note sequence. 0 would be the bass note, 1 would be a half step up, 2 would be a whole step, etc., using scale degree 0 to 12 being the octave. So I can define a major scale, which are scale degrees 0, 2, 4, 5, 7, 9, 11, and backwards. I'll have a melodic minor scale going up, scale degrees 2, 3, 5, 7, 9, 11, and natural minor down, 10, 8, 7, 5, 3, 2. Then I'll have a short major triad, 4, 7, 12, 7, 4, and minor triad, 3, 7, 12, 7, 3, all of which will be played as a sequence, if you will, using a shape generator to move through the indices 1 to 48. I have a preset that I've already constructed we can look at. This uses 5 separate patterns that I've put on oscillators. You can see I've activated only the first oscillator to output right now with a formula that's just pressure, only moving to 0.5 instead of unity. The spectral balance of these are all set to a fixed 0.5 for this video, not quite a sawtooth. Let's look at the formula that I put on the frequency of oscillator 1. This starts with a constant of 40, which will be interpreted as Midi Note 40, which is E2. And to that, I add formula A and convert the result to kilohertz using the note number function. So I'll go in, I'll select note number to kilohertz, and that will convert the resulting MIDI number to kilohertz that's expected as the frequency for the oscillator. Now let's look at Formula A, which is the special sauce that makes this all work. Formula A uses the shape generator 1 in this case, with a ramping function that goes from 0 to 48. Shape generator 1 is W-gated, and its frequency is set to 0.1. It's also set to continuous cycle. So this shape generator will go through its cycle every 10 seconds. Two additional important things. On the ancillary function of A, number 1, I'm going to add 1 to the resultant value because I want to create an index pattern that goes from 1 to 48, not 0 to 48. So I'll add 1, and most importantly, I will select my integer offset graph. And now this new ancillary function will use the value of my shape generator based formula going 1 to 48, ramping through those numbers to play successively the notes in the graph. I have a keyboard attached, playing this through MIDI. On the module, I could also do this playing through CV. In that case, I may have to scale X correctly to the note I want to come out. Let's play our pattern. And because it's a continuous shape generator, you can hear the pattern is being repeated. And also you can hear when it gets to the two notes that are the same, those come out as one longer note. Now, it might be nice to put a macro controller on the speed of this shape generator so I can dynamically change it. So let's create a new formula on Formula J. We'll set that to macro controller 1 that I've already set up in the editor. I'll set Y as a constant to 0.05, which is the slowest speed I want to maintain here. And I'll set J, we'll set that to be maybe 0.2, which will give me about as fast a speed as I want for this. Now we'll stick J as the frequency for the shape generator. Now when I play and set this to its minimum value, I can go from slow and in that way create something that's a lot more useful in terms of how the speed of that shape generator is changed. However, what if I want to offset this based on X? I want this pattern to start on the note that I play on the continuum or on a keyboard attached to the continuum or EaganMatrix module. I have another formula that does something like that. We'll disable the first oscillator and we want to play the second one now. This does something very similar to what the first one does. However, in this case, I've set a continuous function going from 0 to 72 on X, and that gets added to the formula that we had before. Everything gets converted to a note number as we did before. 0 to 72 works out to do what I want here. You can play around with the X scaling if you like. Now if I play, I've scaled this so that when I play a C, it comes out as C. Let me play a note. Let me play on another note. I can actually play two notes at the same time. So my pattern is now playing a fifth apart as I play them on the keyboard. I could even put a chord in, say a minor seventh chord. You can see how this can very quickly become very interesting in terms of usage. Let's go to another option. I've created another pattern. I have a fixed pattern starting on E2, but we could go and use the dynamic X offset that we just used as well. But I'm more after using an offset graph now and not the main graph. What I've done here is, because I can go negative on the offset graph, I can impose a rhythm that would be difficult before. Remember, before, if I repeated a note, it sounded like just one longer note. So now, if I add the next note as -48, that in effect, added to the bass note, will be out of my hearing range. That'll make it sound like a rest is being applied to the pattern, and that will allow me to repeat notes. Of course, my bass pulse now has to be used throughout when I want to have a longer note, and the result you can hear. In this manner, I can create rhythms and rests. Now, of course, you have to be careful. If you start something way too high, this -48, when added to a MIDI note that you have there, might just be in the range of hearing, and you won't get the effect that you want. But I can do something kind of cool. These offsets can be added to graphs that I already have in place. So one thing I could do is simply play them together. So you can create patterns on different oscillators or different EaganMatrix sounds, apply the frequency to that component, and play them both at the same time. Or I could do something like this. I can take the offset and add that on top of the pattern that I already played. So now this will, in effect, create a different set of notes that's adding the first pattern to the second pattern. You could hear, because the offset pattern was not as long as the original pattern, when the offset pattern was done doing its thing, which contorted the original pattern totally, you could hear the ending of the original. You can play around and do a lot of really cool things in this manner. Remember, you do not have to always go all the way through your pattern. Well, let's do one more thing. Let's create a simple 8-note pattern. So I'm going to have a pattern here that will be 2, 4, 5, 7, 9, 11, and 12. All the diatonic notes in an octave. I can play that. Why is it only playing 8 notes and not playing all the rest of them? In the formula that's now E that generates the pattern, I only go to 8. You'll notice here I've selected the second integer offset graph that I'll be using. I add one as I did before so that I go from a value of 1 to 8. And that's why when I play my pattern, I only cycle through the 8 tones instead of the 48. But what I really want to do for this example is use these tones as kind of a set of diatonic pitches, and I'll use a sample and hold to randomly play any one of those pitches. Before we had this graphing function, you need a pretty complicated formula to try and do something like that in the EaganMatrix. But now I can just create a sample and hold of some random numbers in a range of 1 to 8, and they'll play whatever pitch set I create at whatever length I want, as long as I index the right number into the pattern. So what I'll do on H, I'll start again by just using E2 as a bass note. This time, I'll use a similar formula, but I'm going to add G to this, and G, as you'll notice, is creating a sample and hold now on noise. So I'm going to get randomly generated values that will be in a range to 8. I'm going to use an ancillary here that is going to take the absolute value and then multiply, because sample and hold values are going to come out negative and positive. So I want to take the absolute value of that, and in 9.95 we have this new second ancillary function that you can use. Before, we only had one set of ancillaries. Now I can apply a second ancillary to that. So what I'll do is quantize that as well to 1. That will make sure that I'm only going to have quantized values coming out in my desired range. And now, when I apply my formula, I should get random notes in this pitch set. It sounds like some of them are held longer, and that's because it just randomly selected the same note. Now, if I want to add even more rhythmic variation into this, I can take one of the notes in the pattern and just make it go to minimum. So when that note's played, I'll hear a rest. I think you get the idea. This is a very useful tool now that allow you to create these pitch sets, use them as sequences. You can run them front to back. You can run them back to front. If, for example, you wanted to play them backwards, I could use not a ramp up, but I could use a ramp down. I can use sample and hold to randomly play pitch sets that I create. You could create 12-tone structures, perhaps, in this way if you wanted to. It's a very useful new feature that I think you're going to have a lot of fun playing around with.